Welcome back to this lesson series in algebraic fractions. Today we'll be looking at combining the two elements that we learned in the first and second lesson to help us solve equations that involve algebraic fractions. We'll start with some easier examples and we'll progress through to some more difficult examples. So we'll jump straight into example 1, where we've been asked to solve this equation. And I know that I'm going to have to solve it due to the equal sign, where we have got 7x minus 16 over 2 equals 2x minus 3. So there are many different ways to lay out solving an equation. It will all involve the same steps. The way you lay it out may look different to me. That's absolutely fine. If you like the way I lay it out, you can copy the way I lay it out. But if you prefer to do it the way you know, all it means is it may look slightly different in the way that you lay things out. So the first thing we should look at here is we don't like having a fraction. When solving an equation, if we can get rid of fractions, that would be the best thing to do. So the first step that we would like to do here is get rid of this divide by 2. And we know, hopefully, that when we solve equations, to get rid of something, aka remove it from a side, we do the opposite. Okay, so the first thing that we want to do here is get rid of this divide by 2. The opposite of divide by 2 is to times by 2. So we will times both sides by 2. And we have to do it to both sides to keep it equal, remember? And that will give us, well, if I times this side by 2, that gets rid of the 2. It cancels the 2. So this 2 is now gone, which will leave me with 7x minus 16 equals, timesing all of this by 2 will give me 4x minus 6. Now, a really common mistake that students make is they know that they have to times by 2, and then they double these two terms here. So they would have 14x minus 32. That's wrong. Once you multiply this by 2, you are effectively cancelling that 2. You don't have to multiply any of this by 2. So don't fall into that mistake that many students do. Once we have multiplied that out, it's very easy now. This is just a basic unknown on both sides question. When we have got a 7x and a 4x on different sides of the equal sign, the best method here is to take away or move the smallest unknown. So the smallest unknown here is the 4x. How do I get rid of or move 4x? I do the opposite. I take away 4x because that is a positive 4x. Taking away 4x from this side will give me 7x minus 4x is 3x. Still got the minus 16 equals, well, 4x minus 4x, that is now gone, which is minus 6 just left there. Then we can plus 16 to both sides, because I'm trying to remember the goal of this question is to solve for x. We want to know what x is. So if I plus 16 to both sides, I will get 3x equals minus 6 plus 16 would be 10. Now, usually at this point, students feel that they've gone wrong because the last step is to divide by 3. Okay. And if I divide both sides by 3, that leaves me with x, because 3 divided by 3 would be just 1. So 1x, x. And 3 doesn't go into 10. So the best thing that we can do here, and you should be confident doing this, is just leave your answer as a fraction. The answer to this is 10 over 3. There's no point trying to work it out as a decimal. There's no point doing a bus stop and putting 3 into 10. Just leave your answer. Be confident in leaving your answer as a fraction. So 10 over 3 is completely acceptable. Okay, so really focus on having whichever way you lay your solving equations out, just make sure it's nice and clear. As you can see there, I've got all of my steps down the side. I'm showing that I'm doing it to both sides. My equal signs are in line. The more organised you can be with your layout, the easier these will become for you. So that takes us on to example 2, where now we have got a fraction on both sides of the equation. Okay, so again, we're going to do the same thing here. We want to eliminate this divide by 2, and we want to eliminate this divide by 3. So you can do that in one step, or you can break that down into 2 steps. The first thing that we'll do is we'll do it in 2 separate steps, so I don't confuse anyone. If we focus on getting rid of this divide by 2, we'll do the opposite and times both sides by 2. Now remember, if I times this side by 2, I've cancelled that 2, so I'm just left with simply x plus 4. So that's that dealt with. Remember, whatever you do to one side, you've got to do to the other, so we have to times all of this by 2. So if I do that, I can simply times the top by 2, or I could put it in a bracket, but it's easier just to double the entire top of that fraction, so that would be 2x plus 20 over 3. Okay. Now we need to focus on eliminating this divide by 3, so we can times both sides by 3. Timesing this side by 3 will give me 3x, and then 4 times 3 is 12, so that's 3x plus 12 equals 2x plus 20, because I've eliminated this 3. I've cancelled this out by timesing it by 3. Okay, because remember, 3 lots of this, those 3's cancel. So I'm simply left with the numerator. Now it is just a basic. So what you'll find is when you're doing algebraic fraction, solving equations, it will always boil down to something quite simple. So here we've just got an unknown on both sides. We've got a 3x and a 2x. The best method here is to move the smallest unknown, which is the 2x. So we can simply get rid of that by minusing 2x from both sides, which will give me 3x minus 2x is just 1x. Still got the plus 12 equals 20. Remember, the goal of this question is to get x on its own, so I have to get rid of this plus 12 by minusing 12 from both sides, which will give me x equals 20 minus 12, 8. So the answer to this question is x equals 8. Okay, and again, nice clear layout, taking things step by step. You could have done these 2 steps as one. You could have just times this side by 3 and times this side by 2 and just do it in one step, but here I've just illustrated how it's working. Okay, for the next one, example 3. Now we have got not just a number on the denominator of our fractions, we have got 2 terms that involve x and a whole integer. So we've got 5x and minus 2 and 6x and 1. And again, we want to eliminate those. We want to get them off the bottom of the fraction. We don't really want to be dealing with fractions. So the more we can eliminate a fraction when solving an equation, the easier it will become for you. So the first thing that we should do here is, if we focus on getting rid of this denominator first, we can simply times everything by 5x minus 2. And in my other series, I spoke about whenever you're timesing by something that has got more than one term, in this case 5x and minus 2, you should always put it in a bracket. Okay, so what will that leave us with? Well, that will be gone now if I'm timesing by that, so I'll be left with just 2. And on this side, I'm going to have to multiply this 3 by the 5x minus 2. Okay. And I'll just colour coordinate that for you. So I've times that up there. I've still got this denominator here, which now we're going to have to deal with 6x plus 1. And we're going to do that in exactly the same way we've just dealt with the other denominator. And we're going to times both sides by 6x plus 1. And I'm going to put it in a bracket because there's more than one term. So what will that give me? Well, I've got to do 2 lots of this. So that would be 2 lots of 6x minus 1 equals the 3 lots of 5x minus 2. Now this is a simple X is on both sides with a bracket. So here you need to remember, how do you expand a bracket out? So we're going to expand both of these brackets out. Expanding out the left bracket, 2 lots of 6x is 12x minus 2, because 2 times minus 1 is minus 2. And then here, 3 times 5x is 15x. 3 times minus 2 is minus 6. Again, now it's a very simple x is on both sides. Again, same technique. We're going to move the smallest unknown, which is 12x in this case, because 15x and 12x. We're going to move the 12x by doing the opposite and taking away 12x from both sides. If I take away 12x, I'll be left here with minus 2, and 15x minus 12x would simply be 3x minus 6. Again, now we're going to have to get rid of this, because the goal, remember, is to get x on its own. So if I want x on its own, I need to get rid of the minus 6 first and then the 3. So we'll start by adding 6 to both sides. Minus 2 add 6 is 4. You should think about a number line there. And then on the left will just be 3x, because I've got rid of this minus 6. Minus 6 add 6 is 0, cancels itself out. So my last step would be to divide both sides by 3. And again, 3 doesn't go into 4. So you have to be confident. You can leave your answer as a fraction. So my answer is going to be 4 over 3 equals x. So my final answer is x equals 4/3. So as you can see, all 3 of those examples used the same method of eliminating the denominator by multiplying across. And it's really important, as you can see here, my layout looks the same every time. However you lay it out, just make sure you are consistent with the way it looks, and it's organized and easy to follow for you and someone that's marking it as well. If someone was marking these questions here, they could clearly see what I was doing. I'm telling them what's happening on the side. And it's nicely laid out with my equal signs in line. So it's easy to follow, which means it's easy for someone to give you marks. Okay, so that takes us on to the next 4 examples where things get a little bit more interesting. So, there's a few ways that we can approach this question. The best way for us to approach this question is to realise that we have got 2 fractions, x minus 1 over 2 plus 2x plus 3 over 4 equals 1. So our first problem that we should identify here is we've got 2 fractions that are being added together that have different denominators. And then we've also got fractions that are a problem. So there's a few different methods we can use to approach this. I'll show you the way that I do it, which is, first of all, I'm just going to look at my denominators, and I'm going to realise that they're different. So I can't necessarily add these fractions together because the denominators are not the same. And this goes back to the lesson that we did in Algebraic Fractions 2, where we looked at adding and subtracting these types of expressions. The difference here is we've got an equals 1 as well. So the first thing we should do here is, let's make a common denominator. If we focus on this, we could make a common denominator, and we could make that common denominator 4, because this is 2 and this is 4. 2 goes into 4, so we should just make this side, first of all, out of 4, plus this side, which is out of 4. We can leave that because it already is out of 4, so this one's okay. because it's already out of 4. How would I make this one out of 4? What would I do to 2 to make it 4? I would times it by 2. And remember, with fractions, if you times the bottom by 2, I have to times the top by 2. So by doubling this top here, I would get 2x minus 2. 2 times x is 2x, 2 times minus 2 is minus 2. And this still all equals 1. So what you can see now is I've got two fractions that share a denominator. Okay? They share this denominator here. So what I can do now is I can add these together. So I've got 2x, add 2x, which is 4x. I've got minus 2, add 3, which is 1, so plus 1, over the same denominator, 4, and that equals 1. Okay? So all I've done there is, and if you haven't already watched Algebraic Fractions 2, definitely go and watch it, because I explain how that works. But I've made a common denominator, which is 4, and then I've used simple fraction rules and I've added together my numerator and kept my denominator the same, which is just basic fraction understanding. From here, this is just like what we were looking at a minute ago. Don't like this divide by 4, so I can start to solve this now. How am I going to deal with this divide by 4? I'm going to do the opposite and times by 4. So that will give me 4x plus 1 equals 1 times 4 is 4. Okay. And then I'm going to just solve this really basic linear equation. The first thing we should do is get rid of the 1. So I'm going to minus 1 from both sides, which would leave me 4x equals 3. 4 minus 1 is 3. And I'm going to divide both sides by 4. And again, this answer is going to be a fraction because 4 does not go into 3, so the answer to this is 3/4. Or you could write 0.75 if you prefer. But it's quicker and easier to just write a fraction as your answer. So 3/4 is perfectly okay. And you should be confident, again, you should be confident in leaving your answers as fractions. Don't think you're wrong. Providing you've done all the right steps, be confident in leaving your answers as fractions. Okay? So, that brings us on to example 5. Very, very similar. 6x minus 1 over 4 minus, so now it's a minus, 5 minus 2x over 2. And that all equals 1. So again, there's quite a few things that we should talk about here, particularly with this minus. So that's going to be really crucial that we're careful when dealing with that. The first thing we should realise is we've got two fractions that are being taken away from each other, again with different denominators. So I'm going to just use the understanding that we learned in Algebraic Fractions 2 to manipulate these fractions and get them as a common denominator. Well, 4 and 2, we could make a common denominator of 4 again. So we could have our common denominator as 4. So I'm just going to write out two fractions with a common denominator, which is 4, equals 1 because that's not been dealt with yet. We're just going to leave that there. What did I do to the first one to make it 4? Well, it already was 4, so I can just leave that as 6x minus 1. Minus, how did I make this 2 into a 4? Again, I have to double it. So I have to times it all by 2. So timesing the top by 2 is going to give me 5 times 2 is 10, minus 2 times 2 is 4x. Okay, now we have to be really careful with this minus. So I've spoke about this before. If you are minusing something that has got more than 2 terms, you should put a bracket around it. So I'm just going to put a bracket around this to remind myself that I need to do this minus 10 and then minus 4x. And that is really crucial because what a lot of students do here is they only minus the 10 and then they just minus the 4. But as you can see, it is minus 4x, which we know changes everything completely. It becomes a plus. So if we look at this, we're going to have now a common denominator, so we can write all of this over 4. So we can start to tidy up the top now. We can actually take them away. Once you have a common denominator, you can make the subtraction. You can take away. You can simply, like you would a normal fraction, you can just take away the numerators. So let's have a look. We've got 6x minus 4x. And that's really important. 6x minus 4x. Well, if you minus a minus, this is going to become a plus. So this is saying to me 6x plus 4x, which is 10x. And again, if I didn't notice that this was a double negative, I would have done 6x minus 4x and I would have got 2x, which is wrong. So really be careful when you've got a minus and more than one thing. You just put it in a bracket and double check if you've got any double negatives. So 6x minus 4x is 10x. Now I've got my whole numbers where I've got minus 1, minus 1, minus 10. Well, if you're at minus 1 and you take away 10, you get to minus 11. Okay, and this all still equals 1 because we've not actually done anything to the left-hand side yet. Now we can solve using our steps from the previous examples in 1, 2, and 3. The first thing we would like to deal with here is this minus divide by 4. To get rid of a divide by 4, we can times by 4. Again, that would leave me with 10x minus 11. You do not times the top by 4 because, again, as I discussed, when you times this side by 4, you are essentially just cancelling out that 4 at the bottom. So you're left with simply the top. Timesing this side by 4, 1 times 4 equals 4. Now everyone can solve this, yeah. You simply plus 11 to both sides, which would give you 15. We've got 10x over here. Divide both sides by 10. Again, 10 doesn't go into 15, so we can leave it as a fraction, 15 over 10. And if you really wanted to, you could simplify that to 3 over 2. Yeah, 5 goes into 15 3 times, 5 goes into 10 2 times. So our final answer for this question would be x is 3 over 2, or 1.5. Okay. So again, example 4 and 5 rely heavily on you understanding how do you deal with adding and subtracting algebraic fractions by making a common denominator. So your first step is to make a common denominator using the steps we learned last lesson, and then dealing with the algebraic fraction, then multiplying across to get rid of the final fraction. Okay, and again, really organized layout is going to be key for you here. Showing what you're doing to both sides and being really careful when you've got a negative. Yeah, when you're minusing more than one term, put it in a bracket. It's so important. Okay, that brings us on to the final two examples, where on the denominator of these fractions, we have got more than one term and we are minusing them. Okay, so again, the first thing we should do, and we looked at this in the previous lesson, how do we make a common denominator when you have got more than one term on the bottom denominator of a fraction? Well, the first thing we should do, I'm just going to put a bracket around these. Okay. How would I make a common denominator here? Well, we discussed that you can cross multiply, because the only way we can get a common denominator here with these two terms is to just times them together and have them as double brackets. Okay, so what we're going to do is, again, if you haven't seen last lesson, you might want to go and watch it after this, but we are going to multiply the denominators together, and that will give me a common denominator of x minus 2 and x plus 1. Okay. And again, this all equals 1. We're not doing anything to this 1 yet. We're just focusing on this sum here. So now ask yourself, how did I make this side become this? I times it by this. So that means I need to times this entire fraction by x plus 1. And I need to times this entire fraction by x minus 2. Because the only way that I can make this x plus 1 become this double bracket times together is by timesing it by the missing x plus 2 minus. And remember, if you do that to the bottom, you have to do it to the top. So we need to times this top by x plus 1. So I'm just going to leave it in a bracket. I'm just going to say 6 lots of x plus 1 is what goes here. And then for this bit, I've got minus 6 lots of x minus 2. Okay. So we can tidy up the top now. We've got a common denominator. We can tidy up the top. We're going to start by expanding out both of our brackets. So we've still got x minus 2 and x plus 1 on the bottom. Still equaling 1. If we expand out the top bracket, we've got 6 times x and 6 plus 1 times 1. So that is 6x plus 6 for that bit. And I'll just highlight this so you can see where it's coming from. Now you'll be really careful here. Remember, I've said this a lot in my lesson series. This minus is not floating. It is attached to this 6. So we're actually timesing this whole bracket by minus 6. Okay, and that makes a massive difference. So minus 6 times x is minus 6x. And this is why it makes a massive difference. Minus 6 times by minus 2. A minus times a minus is a plus. 2 times 6 is 12. So that would become plus 12. Okay, so if we can continue to tidy at the top, we can now collect some like terms here. We've got 6x minus 6x. Well, that's going to be gone. That's going to cancel. They cancel each other. Then you've got 6 plus 12. Well, 6 plus 12 is 18 over x minus 2 and x plus 1. And that all equals 1. So what we can do now is times up. Okay. So I'm just going to bring this up here so we've got a bit more space. So these questions are quite long. They do have a lot of marks awarded for them in exams because it's going to rely on you having lots of skills. So how do I go from here? Well, I've got a denominator with loads of x's that need to be expanded out. So the first thing I'm going to do is I'm going to times this denominator up here, okay, like we would normally. If that was just a number on the bottom of here, we would just times it up. Okay, so we're going to times that up. Well, that would leave us with 18 equals, well, 1 times this whole set of brackets here is going to be just itself, x minus 2, x plus 1. Okay. So what we can do from here is expand out this bracket. So we can get 18 equals, and if we expand out here, we would get, and again, this is me just assuming you can expand out double brackets. I have done it in previous lessons. X times x is x squared. X times by 1 is plus 1x, or just x. Minus 2 times x is minus 2x. And minus 2 times 1 is minus 2. So I've still got the 18 equals. If I tidy up this, obviously, hopefully you know whenever you expand, you end up with two terms that can be added together. So here, you can have x squared, x, take away 2x is minus x, and then minus 2. So that yellow bit went to that. When you've got a quadratic, to solve a quadratic, you would like to make it equal to 0. So we're going to make this quadratic equal to 0, which means we can take away the 18 from both sides. So we'll get x squared minus x minus 2 minus 18 would be minus 20. So now we have a quadratic that we can solve. So as you can see, we've done a lot here. And we're still not done. We still need values for x. But just to sort of recap how we've got to the point we're at. We've, first of all, made a common denominator by using our understanding from last lesson, by cross-multiplying, essentially. Then we've had to do some expanding, which has a negative, so that is difficult. It usually catches students out, but as long as you're careful and follow the advice that I've said, you'll be fine. Then we've simplified that expression to get just 18. And then we've multiplied up to get a double bracket that needs expanding. We've expanded it. And you should know that when you have a quadratic, you have to make it equal to 0 to solve it. Okay? And that just relies on your understanding of how quadratic equations work. So once we've made that equal to 0, there are many different ways that we can solve a quadratic. Okay, we could factorize. We could use the quadratic formula. We could complete the square. Okay, there's many different options. In this case here, if this was a non-calculator paper, we should try to factorize. So we're going to try and factorize here. How do we factorize a quadratic? Well, the first thing you should know is this is equal to 0. A quadratic would factorize into two brackets. Okay. A quadratic will always factorize into two brackets if it is a generic ax squared plus bx plus c. How do we factorize? Well, I factorize like this. Remember, we need two numbers that multiply together to make minus 20 and add together to make, in this case, what does minus x mean? That means minus 1. So we need two numbers that multiply together to make minus 20 and add together to make minus 1. So the best method you can do for this is list out your factors of minus 20. What makes minus 20? Well, remember, to make a negative number, you need a positive and a negative. You need a mixture. So we could say we've got minus 1 and 20. Because if you multiply those together, you get minus 20. You could have the opposite. So you could have positive 1 and minus 20. So you can always have the reverse. You could have minus 4 and plus 5. Or 4 and minus 5. So that is all of my factors that times together to make minus 20, yeah? If you times any of these pairs together, you will get minus 20. You should now look down this list and see, do any of these add to make minus 1? Well, minus 1 add 20 is minus 19, so that's no good. So it's definitely not the first one. 1 take away 20 is minus 19. so that's no good. Minus 4 plus 5 would be positive 1, which is no good because we need negative 1, so it can't be that one. And 4 minus 5. Well, what is 4 minus 5? 4 minus 5 would give me minus 1. So that is perfect. That's exactly what we need. So the pair that we need, the numbers that we need are 4 and minus 5. So inside my bracket, I can have x plus 4 and x minus 5. Okay. So when I factorize this quadratic using the technique I've just shown you, you would have x plus 4 and x minus 5. And if you are doing quadratic algebraic fraction questions like this, you should be able to factorize. And if you can't factorize, or you're a bit rusty on factorizing, it's something that you need to be able to do. It's almost, if you can't do that part of this question, you can't actually get to the answer. So make sure that your factorizing quadratics is fresh and up to date in your mind. Where do we go from there? Well, once you factorize the quadratic, it's easy to get the answers. You just have to make these two brackets equal 0. So what makes this bracket equal 0? Okay, because remember, this is basically saying this multiplied by this equals 0. Well, you should agree 0 times anything will always give me 0. And anything times 0 will always give me 0. So as long as I can make both of these brackets 0, I will have the answer. So if we focus on this bracket, what makes that bracket 0? What would x have to be to get, what would you add 4 to get 0? Well, x would be minus 4. Yeah, minus 4 add 4 is 0. And 0 times whatever this is, yeah, minus 4 minus 9 would give me 0. Same thing here. What makes this bracket 0? What do you take 5 away from to get 0? Well, 5. So x would be plus 5. And you can probably spot a pattern there. It's just a reverse of what you've got. This would be minus 4, and this would be plus 5, yeah? It's the opposite signs. So my two answers, this has actually got two different solutions for this question are x equals minus 4 and x equals 5. So big question, usually 5 marks in an exam. Very, very big question. And as you can see, it requires you to have understanding of a lot of different aspects at the GCSE higher level. You need to know algebraic fractions and making common denominators with x terms on the bottom of the denominator. You need to know how to expand brackets. You need to know how to simplify. You need to know how to cross multiply, expand double brackets, factorize quadratics, solve quadratics. There's a lot going on there, but hopefully you managed to follow along. If you didn't quite get every step, maybe watch it back. But what I want you to do as your task is to try and use all of my understanding and application that I've done in example 6, and I would like you to have a go at example 7. Okay, so I'd like you to try and replicate the process I did on this last example onto example 7. Okay, make a common denominator by cross multiplying. Yeah, that's your first step. Get a common denominator by cross multiplying. Work out what needs to go on the top, and then follow that process with the quadratic. And I'll post the solutions to example 7 in the description, and you can see how you got on, and if you got a little bit stuck, you can review my solutions and see what happened. Okay, so thank you for tuning in. Hopefully you managed to follow along with those examples and learn something. Takeaways from this is your layout's really important, making sure it's clear, and making sure you understand the basics of algebraic fractions and quadratics. And if you're unsure on any of that, go back and look at the previous 2 algebraic fractions lesson. So thank you for tuning in, and I'll see you in the next one.